Hey folks, Copperthumb here. In today's video, we're going to talk all about non-manifold geometry, holes in our models, and other issues. This is a video I wish I'd had at the beginning of my 3D modeling and 3D printing career. It is exceptionally helpful. So let's look at what these issues are, how we can fix them, and how we can prevent them happening in the future. So without further ado, let's dive right in. Okay, so when we're talking about non-manifold geometry, we need to think about our manifold model and what that actually is and why it's important. Well, I want you to picture a balloon. Now, a balloon has a clear outside, a clear inside, and obviously the shell itself, which would be our model in this case. Now, if that was completely filled with water, we want it where none of that water can leak out anywhere. This is important because that's also how our slicing software wants to see our model. It wants to see a complete model with no gaps, no weird floating artifacts or other things inside, just a shell, a clear outside, and a clear inside. This is how it's going to build that model in the slicer with code so it can 3D print it layer by layer as we go. Now, when we look in Blender, that's not always the most obvious thing to see. The model can look perfect, but it can have minute gaps that can create all sorts of issues down the way. So let's look at what those issues are, how we can find them, how we can fix them, and how we can prevent them, starting with the most obvious, holes in our model. Okay, folks, let's start with our old friend, the default cube, as our example. Now, on first look, it looks pretty good. But if I flip him over, we can see there is a hole in our model, non-manifold geometry. As we explained earlier, all the water would leak out of this hole. So we can fix this one really quickly because it's obvious and we can see it. So if I hit 2, I can just select these edges, or I can select one edge and then hit Alt and click it to select all the edges that'll run around, and then hit F to patch it with a face. That is great. But there are a couple of other issues with this model that are less obvious. The first one being, with that face selected, or any of these faces selected, if I hit L to select all the linked geometry, you'll see it only selects half the model because only half the model is attached. If I hit G to grab this on the Z-axis, you can see they are not connected. So one quick way to fix this, and this would work for your full model and can solve a lot of issues, is if you hit A to select all, and then hit M to bring up the merge menu, and then you can merge by distance. Now, this would solve that problem for any overlapping geometry as long as it is perfectly lined up. If it isn't, then this might not be the solution. Now, how do I see where the issues are? Well, thankfully, Blender ships with an amazing tool, an amazing add-on that comes with Blender that makes our lives so much easier for this. So if I go into Edit, Preferences, and if I search for 3D Print Toolbox, 3D Print Toolbox, you'll see that it pops up here, and this is exactly what we need for finding these issues. So I just install that real quick. It comes up with this tab right down here. Now, what we can do now is we can check our model. So if I hit Check All, boom, it's going to show me I have 12 non-manifold edges and 2 shells, the 2 shells being the 2 halves that aren't connected. Now we want one shell and we want no non-manifold edges. So if I click this little button, it will show me where those issues are. Now, very interestingly, it's shown running around this model, which we already were aware of because that's where the model split, but it also shows this one at the top. Now, if I zoom in, look at that. There is a hole in my model. Super cool. Now, what I would do for this is I would go into edge select mode, vertex select mode. I would select that vertex. I can select that vertex, and then I can hit merge at last. So it will merge the first vertex or all the vertexes before the last one. And then if I hit merge at last, it's going to connect those together wonderfully. Now, if I hit check all again, it only has 8 non-manifold edges, which we know are the 4 running along the top here and the 4 running beneath the bottom. So if I select all of those, and I know they are directly on top of each other because I can see they are, and I did it. Now if I hit merge by distance, and then I hit check again, we've got 0, and we've got 1 shell. Amazing. Now the overhang faces, we don't need to worry about that, but they are these faces all on the bottom, which would be an overhang, but they would be sat on our printing plate, so it doesn't matter. So yeah, That is a really easy way to find all of these issues and just solve them very quickly. 3D Print Toolbox is your friend. Now, there are other solutions we can find, so let's look at a couple of other more complex issues and how to solve those. Okay, so let's look at two other issues that are also harder for our 3D Print Toolbox to catch, and that is inside faces and also theoretical geometry. And what I mean by that is right now we have this cube, which looks pretty perfect. If I hit check on 3D Print Toolbox, yep, only has one shell and no non-manifold edges. So it's saying it is a manifold model, which technically it is. However, if we were to 3D print this, it wouldn't come out how we expect. And that is because right now this cube is being generated, or half of it is being generated by the mirror modifier. Now, if I turn this off, you'll see this is the shape that we actually have in our scene. This is what is editable by us. This is what exists. Now, the mirror modifier basically creates theoretical geometry and then, mirrors our actual model. So this is, on this side, is literally just what could be if we were to apply the mirror modifier. And that means that it's not always going to show up using the 3D Print Toolbox. Now, what we'd have to do is apply this. So if I go into object mode and then I apply this, now we have it. Now we have our cube, which is great. We can edit each side individually, whatever. But if I check, we have 4 non-manifold edges. Why is this? Well, that is because something you have to watch for all the time with the mirror modifier is if I zoom right in, there is a face between these two edges, which means that we now have two basically compartments in our model, and interior faces can mess up slicers all the time, something we really need to watch for. Now, our 3D Print Toolbox can catch this. There you go. You can see that it has found that. So a way to fix that is we can just zoom right in, go into Face Select, and then delete that face. And then there you have it. And then if I check again, perfect. It has got rid of that issue. That's the easiest way to do it. Now, obviously, with more complex models, you will have to search them all out and find them and remove those faces and just do your best to clean up. But mainly, building your model to try and avoid that, to try and avoid those interior faces is the way to go. Okay, there's one last thing I want to show you, which is can be a big fix when you're in a pinch, but it is a bit of a brute force system, and a lot of people would not like it for animation or games, but for 3D printing, it works perfectly. So let's have well, not perfectly, but let's have a quick look at that right now. So last but not least, one of the ways you're undoubtedly going to create non-manifold geometry is by using the Boolean modifier. As you can see here, I have attached a bunch of cubes together, and I've also just dropped in some cubes without using the modifier to show you that I've created all sorts of horrible internal geometry. If I use our 3D print toolbox and I hit check, you can see here I have 22 non-manifold edges. I have 10 intersect faces, 2 shells, 3 non-flat faces. It's all bad. Now, what happens if it gets so complex and you're like, surely there is a quick fix? Well, there is, and a lot of people love it, a lot of people hate it, but for 3D printing, it works perfectly. I would not recommend this if you were using it for games or animations or things like that. But for us, for 3D printing, it doesn't matter if we have ugly topology. It just matters that it's one manifold object. So if I want to fix all of this crud inside here that's looking really bad, I can do that by using a different modifier. And this modifier is called the Remesh Modifier. The Remesh Modifier is going to procedurally generate us a manifold object by looking at basically everything that it has in front of it and then creating a new shell. So if I click the Remesh Modifier, you'll see here that the resolution goes right down. And now you can change this by either into voxel, sharp, smooth, or blocks. Blocks obviously works very well in this instance because we're using blocks, but if we're using the voxel, we can decrease the voxel size to increase the resolution of this. Now, even if I take this down from 10 centimeter to 1 centimeter, boop, and it calculates, you'll see it doesn't have perfectly sharp corners, but with 3D printing, it's never going to have perfectly sharp corners because it's using 3D printed filament that is coming out as a tube. So usually this will work for us in most cases. Now, be very careful. If I decrease the voxel size further, it can crash your computer because it is increasing the amount of computing that needs to be done. If I apply this modifier and then go into edit mode, you will see how much resolution this has added. So use this sparingly. It can fix things, but to reverse out of this can become very difficult. But if you're in a pinch, the Remesh modifier can really help. I've used it so much of the time to get me out of a tricky situation with a 3D print that I'm too far down the line in. But that is it. That is my explanation of non-manifold geometry and loads of ways we can fix it, find it, and yeah, to prevent it in the future, just be clever about the way we build and the way we think about our models. So yeah. And there you have it, folks, a quick guide on how to understand non-manifold geometry and how to fix it. I hope you found this video really useful. Understanding these fundamentals of 3D design will really help you with your 3D printing journey. So try and embody this, go back to parts of the video and just practice on your own. If you found this useful, please like and subscribe. It goes a long way. I really appreciate it. And as always, there'll be new videos every Friday showing you new techniques or how-tos or building different models. And if you should be so inclined, check out my other socials, TikTok, Instagram, or even check out my Patreon. I've been Copperthumb. You've been awesome. I'll see you in the next one.